Continuing with spatial information with R, we're going to see the raster data in the raster package. So let's begin by uploading the raster package. And these are several functions that have help. And this is a large package that contains many different functions. So it's possible to do a lot with this. And we are going to explore a very small fraction of everything, a very basic part of it. But this is a package that allows us to do a lot. So I'm going to leave all this here as a reference. So the first thing we're going to do is to read the data. This is organic carbon in the soil that's in the TIFF format. It's a very common format for raster data. So I'm going to use the stack function that allows me to read rasters with multiple layers, but you can also use the raster here because this one only has one layer. So I'm going to read it here. So it creates an entry point in the global environment of this variable that I just created. So this is the class, raster stack, the dimensions. So this would be 837 rows and 885 columns. And the total of cells would, and this will be the total of layers. I only have one layer in this raster. Then the resolution, this file is in degrees, so the resolution would be in degrees. It would be equivalent to 250 meters approximately. The extent, which would be the geographical window where this data is located. Then the reference system for coordinates, it's in longitude and latitude. It's a very common format for this type of work. And names, it will be the names of the layers. So it only has one layer and it's called layer. And then the minimum and maximum values here. We're probably using these. And this is incorrect because these are the values to represent the data that are available. We can also create a very simple and fast plot by using the plot function. So this is the information that I have available. It would be this raster. I have values here close to 0, 0. That would be where the water is, where the ocean is, and also where the lakes are would be in white. And the values would reach 100. These are the coordinates, latitude and longitude. And this would be the rest of the values. You can also use other functions for description in R. And this can be used to do raster. For example, here I can see the 0 values where I have no data, and then it begins with 30 and it goes up to 100. And since the raster has a lot of information, in order to avoid being too heavy, too big, it uses just a sample of 13% of the cells. And this is important because this wouldn't change a lot because I already have a lot of data and the file would be too large in the raster. One of the things that we can do with the raster is to change values. So I can use that to define a criterion. This would be a raster for true or false. So where my value is equal to 0, I'm going to change this. These are the garments to do a selection, but if you combine these, it's a function that allows me to change the values. So I'm telling R here to change all the cells that have a value equal to 0, and I'm going to change those to NA, which is the value that R represents to show not available data. And this is going to change the way how the other functions treat these numbers. So I'm going to run my plot once again. And now what you can see here is where I had 0 is transparent, meaning that there's no data available. And my minimum value is close to 40. So now it's interpreting what I have, the values that I have. And I could see the same thing in the histogram. Now I have all these 0 values. And one more thing to practice, I can also change, if all the values that are over 100, These are values that will be an outlier, an extreme value, for example. It's useful to have this type of option available. So I'm going to change all values that are over 100. I'm going to leave them as 100. This is just to show you the type of things that you can do with the raster. I'm going to run the plot once again. And now my map looks a little bit better. You can see more differences because my limits are more restricted. So the values are very low in this part, and values that are higher where the elevation is higher and the weather is a little bit colder. The new histogram, you can see that the maximum value was 100. We can also create a category map. So I have a criteria that transform value into a true or false. And I can use this to do a map, for example. So everything that's in green are the pixels where the carbon content in the soil is over 50. So this can be very practical too. And something else that can be useful is how to change the spatial resolution. So you can reproject it in the raster for other coordinate system, or to maintain the same size in the origin of the cells in order to facilitate calculations between different sources of raster data. But there's another simple function that's called aggregate that it's only going to add the data, will aggregate the data. So I'm going to aggregate the data that has 10 factors. So every 10 cells are going to transform into one cell, meaning that the spatial resolution that was in 150 meters now is going to be 2,500 meters. So this is going to change the number of cells. We had like 740,000 cells, and I'm going to use the aggregate function, and this will throw me 7,000 cells back. So I have 6 times less information in this case, and many times if you want to carry out some type of analysis, this can be very useful to maintain a lower resolution. Now I'm going to do a map. The map is very similar still. We're seeing a very small map, so this you can't see too much of a difference. And something else that I would like to demonstrate is that you can apply all the different functions, and they can be applied on one vector in R or over a number, or they can be applied on the raster because R works with vectors, so it understands how to do it. For example, in this case, I'm calculating the square root of the values of each cell of this raster, like in a matrix. And the spatial pattern looks the same, but the scale changes. So the values of the square root, this is just an example of everything that you can do. So this shows you all the different functions that you can use for numerical or vectorial data. It can also be used on the raster. There's no need to do anything special. And finally, I'm going to save this result in the computer. And to do this, I'm going to use this function called write_raster from the raster package. And this is used to save in the hard drive. The first argument would be my raster. This is the variable where my raster is. I'm going to use this one with a reduced resolution, and then the name of where I want to locate it and save that data. I'm going to save it with this name, and finally I have an overwrite function. In case that this file already exists, I would like to overwrite it, and I choose true if I want to overwrite it. So with this, we finished the raster data. It was very fast, very simple. The package has many different available functions. They're very powerful, and you can do many things with them. So this initial part was just a way to show you how raster data can be managed with this package.